Hey everyone, my name is Tony. I'm one of the founders at Talent Pluto. I'm the founder and CTO, and I'm a grad student as well at DePaul. And just to hear talk about voice agents and specifically about RAG and memory, it's a subject that I follow pretty closely, and so just wanted to share a little bit about how we do it here at Talent Pluto. So let's get right to it. So part of how you want to think about voice agents is that voice agents need what I call perfect memory. And the way you have to think about it is that the modern LLM has only a finite amount of context across multiple interactions, which can cause frustrations and repeat information that users just simply are frustrated and annoyed about. And something that we do at Talent Pluto is that we conduct thousands of recruiting calls with voice agents every month, and we understand intuitively that candidates expect the agent to remember their skills, preferences, and previous conversations. And so without memory, the agent might ask the same question repeatedly, and it destroys trust, destroys engagement. And so our big challenge we face is how do you give a voice agent perfect memory that understands context and can evolve over time? And so one of the first things we realize is that vector search is just not good enough. There are a few problems, but the two that I think are very important is that vector embeddings capture some amount of meaning. It's not a lack of meaning. It captures what I think is that misinformation. And what that means is that if you try to say, hey, find someone who worked at companies that are similar to XYZ corporation, the vectors don't intuitively understand relationships. They don't understand under what umbrella of a B2B SaaS company might fall under. And I think the second part, which is really important, is that there isn't a temporal context. You see, vector search treats all information equally, whereas we can see internally that a candidate named Sarah might say, "Hey, I was looking for a job 6 months ago," and talk to our agent Pluto, and our voice agent hears, "Oh, Sarah is looking for a job now," which Sarah looking for a job is will pop up on search for semantic reasons, but it's fundamentally different meanings for any human, and therefore a very good voice agent. And so another thing we realized that you want to use multi-hop reasoning, and vector search just not does not provide that. And multi-hop reasoning requires graph traversal across multiple hops to connect candidates and companies, their skills, their timing of when they're looking for a job, or a multitude of reasons throughout their relationships. And so all these limitations reveal why pure vector databases are lacking. And in production RAG systems, it's important to use graph databases. So the way to think about this is what I call, a three-layer memory architecture. So when you're creating memory, it's important to understand that an LLM on its own has some short-term memory. It has a finite context window. You might hear that there's a million context window, 272,000 tokens, and that's really good for next token prediction. But one of the big issues is that if you want really low latency voice responses, you typically use a specific amount of tokens for immediate conversation history for real time response generation. And part of it is you have to combine that with working memory, which is how you retrieve any data from a graph database. And so one of the approaches we have, which we'll talk more about, is a hybrid method of using vector embeddings and graph traversal to fetch relevant context. And essentially what the third aspect of what you see here is long-term memory. The 2.5 million edges you see here is just a arbitrary number. What you really need to understand from here is that a full graph database which can store historical context across time, across preferences, across a multitude of relationships, past interviews, feedback. That's really the magic part of the dynamic part of creating a powerful voice agent. So, most people understand RAG pretty intuitively. You have a voice input when it interacts with a user. You transcribe that information, which will, identify what relationships there are, entities, and intent. And after you do some kind of hybrid search, you
Sorry to
build some.
interrupt you.
Sorry?
You've stopped sharing your slide deck.
Oh, I'm so sorry. Thank you for capturing that.
Yeah.
Please let me know if it's working now.
Yes, we can see it.
Oh, okay, cool. Awesome. Sorry about that, guys. But as I was saying, you want to build context and you bring this together and it basically gives an output all in sub 100 milliseconds or sub 200 milliseconds at least, while it's generating the context and memory from history using LLMs. And so this is just an AI generated image here. This isn't actually what we have. It's just an image from what I drew on a pencil. But what you should focus on is like the key entities when you have a multi-hop reasoning effect. So if you have a candidate that has some aspect of where they worked, what university they graduated from, or intuitive things that they might have said in a conversation, such as where they want to work now, what their past experience has been, are they charismatic? Do they have experience in selling to someone else? If it's a go-to-market role, whatever it is, you need to capture these entities, which can be grouped in multitude of properties. And the way you do that is you take into account where have they worked at, their skills, their preferences, which is really where the magic of multi-hop reasoning comes into play. And so you see 2 to 3 relationship hops, but it can sometimes be a lot more than that. And sometimes it could just be 1 to 2. And so the way that we talk about it, or the way that we use internally, is we like to call it hybrid RAG, which is a very common method of combining vector and graph search. There are other architectures that people might have researched about. One very famous one is called light RAG, or it's getting popular. And so there's an aspect here where our production RAG is using 2 parallel paths that complement each other. So one is vector search, as I mentioned, on its own is just not good enough. But it's still, even if it's not good enough, it has some good aspects of finding semantic search, finding aspects of a transcript where it's necessary. Graph search on its own also has some issues, but it can traverse these multi-hop reasonings and capture relationships, which is an incredibly powerful thing to do. And so what you really need to do here is the equation is honestly not what we use today. It's only V1 of when we started building this, but you can understand an aspect of this equation where you're capturing a score of the vector similarity and how recent was the information. I write confidence, which is just a random number of what it really is, but there's an aspect of certainty and connectivity that you need to match for all these relationships for any given semantic match. And so there's been research that's been done in this field, not by me, but much smarter people than me. And one thing we've noticed is that hybrid RAG actually, based on what domain you're in, it can achieve up to 87% context relevance for the approach that it has, which, as you can see, comparing with just graph only or vector only, that's a very large improvement, which can give performance gain that a hybrid architecture can help when, which helps in the hybrid architecture because it's worth it, because it's so complex and yet it's so helpful when you're building a production RAG system. And so one thing I'll say is when you're building there are challenges building, what I call confidence weighted edges. Voice is inherently uncertain. People say things that might not make sense. If you ask them, hey, where do you want to work? They might say, I'll work anywhere. And in another call, they might say, hey, I actually prefer New York City. So it's important that if you worked with, typical Postgres databases or vector-only databases, you don't want to, you might be able to store this data, but vector-only, as we've seen before, doesn't know what to do with that. And so instead of like deleting or overwriting information or the opposite of just constantly aggregating information, what you want to do is create multiple edges with confidence scores, timestamps, and evidence of where they said it and when they said it. So the example given here is another example which I like. Someone says that I love startup chaos, but it turns out that they say I want to work at a Fortune 500 company, which are completely different preferences. But our voice agent can understand, when that temporal aspect is there and how confident were they when they mentioned these things. The image below that you see here is just a very, very small snapshot of like thousands of relationships created with one singular candidate, actually. So it's a good way to showcase how graph databases can capture meaning when it's very difficult sometimes to convey that. And something else we actually, there's a very famous company called Supermemory, which does an incredible job of talking about this, and I have to give credit to them. But there's an aspect of temporal decay, which, if you think about how humans speak to each other and how humans interact with others, there's an aspect of how we might forget things, and the more recent it is, the more likely you remember it. And so that's the way we want our voice agent to work as well. This is, what you see as half-life is just what I said internally because I studied physics and material science, and half-life is a very common thing that you might learn in chemistry. But there is an aspect of that where you want to create a decay function that basically understands that, the older the context of what someone said is, maybe you should reduce the confidence, because as people progress in their career, the more likely that what they say later on is what's more relevant and what's more important. And so how you might see it is, I love using this example, but when a candidate like Sarah or John says that, hey, I love startup chaos, and then later they might say something like, you know what, I actually want more structure. I want to work at a company where there's a 401k or whatever. That's really important, because it's important to understand that confidence changes, and more importantly, their historical preference is something that is a relevant aspect of how the decay function works. For the sake of time, I'm going to move a little faster, but it's important to say again that as you're building any voice agent in production system, it's important to understand scale. It's easy to crumble under scale, but with multiple graph queries, it's actually, no matter the graph complexity, it can be pretty helpful that the response times can be, with this hybrid RAG, it can actually work really, really well, and enables a very natural conversation with candidates who've told us that they love that, Pluto remembered something that I mentioned before, which is really the magic of agents and AI in general. And so what I like to think of, where we're going to build specifically in the domain that we work in, is how you recognize how good a candidate is across multitude of industries. So someone who's good in engineering, could they be good in go-to-market? Could they be good as someone who wants to work in a completely marketing field or whatever? That's something that we want to grab and graph with multiple nodes, whether it's a voice call, text, email, video. Those are properties that we think can be used in real-time graph nodes. And this is just a vision that we have of, potentially in the future, we might, hopefully by the end of 1 year, we might reach the point where we might have 250,000 candidates. And part of it is hopefully next year when I do this, I'll present another conversation about how that initial aspect of 2.5 million edges might create a compounding effect where you can have 50 or maybe 100 million edges for a given set of candidates. And so the real takeaway that I would give from today is voice agents need memory. If you're building a production voice agent, it's really important to use GraphRag, a hybrid RAG system with graph databases. And that's because graph enables relational reasoning, and hybrid architecture is so relevant, it's powerful, and it provides a percentage point improvement that's way more important than, way more relevant than any other RAG system. So Thank you guys so much. I believe that's my time up, but yeah, thanks so much, guys.